Hello, in this video we are talking about section 7.7 on differential equations. Now we have talked about exactly what is meant by a differential equation and an initial value problem, and we've also talked about separable equations. Separable equations are equations that can be written as a function of your independent variable times another function of your dependent variable. So essentially you can factor your equation into one factor involving your independent and one factor involving your dependent. From there, then you can separate your equations, so you move all of your y's to one side and you move all of your x's to the other side, and then you integrate both sides. So that is how we are going to solve this differential equation, dy dx equals x squared over y squared. We can multiply both sides by y squared so that we get a y squared dy, and then this equals x squared dx. Now we integrate both sides so that we get 1/3. Notice we're integrating the left side with respect to y. So we're going to have a 1/3 y cubed. Technically we'd have a plus c, but I'm going to add a c on the right hand side, so I might as well just combine all of my arbitrary constants into one. So I'm going to hold off on that. Then with an x squared dx, now we're integrating x or something with respect to x, so we'll have 1/3 x cubed, and then we'll have plus c. Let's go ahead and solve for y. So that we can get our solution. So we have y cubed is equal to x cubed plus 3c, and then taking the cube root of both sides, we get y equals the cube root of x cubed plus 3c. Now c is just an arbitrary constant. If we multiply it by 3, it's still an arbitrary constant. So you could write this as y equaling the cube root of x cubed plus k, if you wanted to notate that k is equal to 3 times c. But in all honesty, I would also take y equaling the cube root of x cubed plus c, because like I said, c is an arbitrary constant. You multiply it by 3, it's still an arbitrary constant. So it's pretty common when this sort of algebra with arbitrary constants is happening, when it's being written out, you just always write the same letter, even though technically it's a little bit of a different constant, but you don't know what the c is here, so you don't really know what the k is there. All right, so you can simply write it as just a plus c plus a k plus 3c. I would accept all of these for answers here. So this equation is the solution to the differential equation dy dx equals x squared over y squared. So that answers the first sentence in this example. The second sentence is to find the solution for this equation that satisfies the initial condition. So if y of 0 equals 2, let me go ahead and box that in so we know that's part of our answer. If y of 0 is equal to 2, then y of 0 is equal to the cube root of 0 cubed plus, let's just go ahead and use c. And this is equal to 2. So we have the cube root of c is equal to 2, so that means that c is equal to 8, or 2 cubed. That is not the final answer to the initial value problem. The answer to the initial value problem is this c value plugged into the solution that we had written above. So the solution to the initial value problem is y equals the cube root of x cubed plus 8. And that is our answer for the second sentence.